Okay, welcome everyone to our last session of EMO and our second session on LLMs. Thank you so much for staying until our last session of the day. Today we're going to start with a presentation on racial steering by large language models, a prospective audit of GPT-4 on housing recommendations by Eric Justin Liu.
Hi, everyone. So my name is Eric Liu. I'm a second-year PhD student at the MIT Institute for Data Systems and Society, as well as a member of the housing vertical of the Initiative on Combating Systemic Racism. So I'm presenting some work today on a large language model audit that we conducted on GPT-4's housing recommendations. And this was joint work done with Peko Hosoi and Catherine D'Ignazio, who lead the housing vertical, as well as Wonyoung, a PhD student in the MIT Department for Urban Studies and Planning. And I know that it's almost 4:30, it's in the afternoon. I'll try to kick off the last session of EMO with energy and vigor. So, yes, wonderful. So as a motivating example, I'm just going to talk a little bit about housing discrimination and the history of it in the US. I'm going to be talking about Boston as an anecdote. And so this is an image of the Homeowners Loan Corporation's redlining map of Boston. And these kinds of maps were put together in the 1930s and 1940s as a way to sort of determine areas where federal mortgage assistance should be directed towards, right? So you see areas in dark green, which represent the regions that HLC determined were most mortgage secure, and then the red sections which were determined as being insecure and unsafe to invest in. And around this time, we also have sort of insolvency due to deindustrialization of the middle class. We also see a rise in the number of minority communities in Boston as a result of immigration from China and Europe, as well as a near doubling of the number of Black residents in the area. And so we start to see kind of these pronounced lines of spatial segregation by race and by socioeconomic status appearing in these maps. And that's very much captured by kind of these investment patterns as well. So should also say that nearly 3/4 of the minority residents of Boston only resided in 14 census tracts in the area. So redlining is an example of the kinds of housing policies that resulted in a legacy of disinvestment in neighborhoods of color due to the sort of historical association made by these kinds of policies between socioeconomic status and race. And in 1968, Title VIII of the Civil Rights Act, also known as the Fair Housing Act, sort of saw that these patterns were developing, and the goal of this legislation was to prevent redlining, racial steering, other kinds of racist housing policies from continuing in the US. But we do see really stark and staggering sort of intergenerational effects of these policies down the line. So in order to study the effects of policies like this, fair housing audits were conducted in person by HUD, so the Department for Housing and Urban Development. Sorry, the slides are not tracking, but I'll just go ahead and talk through these. Okay, wonderful. So this study was in 1989. It showed that 21% of Black and Hispanic homebuyers were steered from predominantly white neighborhoods towards neighborhoods that were marked by more integration and also lower wealth. And so these kinds of audits were done by sending matched pairs of auditors or actors towards sales and real estate agents in order to test for differential treatment in housing recommendations. And so I should define racial steering at this point is when minority home seekers are directed towards or away from certain neighborhoods on the basis of race, or in a more sort of nuanced definition. They're not made aware of certain property listings that may match their search criteria, also on the basis of race. And so this was done in 25 major metropolitan areas in the US with 2,100 pairs. And racial steering still happens today, so that was the first study done in 1989. We also have a HUD study done in 2021, which is fairly recent. It shows that racial steering isn't a thing of the past, it's still happening today, and a result, it's deepening sort of the existing inequalities caused by historical discriminatory policies like redlining, right? So in this particular paper by Hall et al., we see that racial steering is happening. It predominantly affects Black women with families, and it plays a moderate role in sort of deepening the spatial segregations by race in particularly urban areas of the US. So this sort of grounds our study and motivates existing literature in the housing and urban development domain on auditing fairness in housing recommendations. The impetus for this particular project was driven by these news articles that came out in 2023. So a handful of real estate companies started developing ChatGPT plugins in order to automate their housing recommendations in 2023. These were actually quickly pulled down from OpenAI's website following some internal audits and due to concerns over housing fairness. And so subsequently, all future ChatGPT plugins related to housing were banned. But we see this very much as an example of sort of the existing interest by real estate companies in integrating large language models like GPT-4 into socio-technical systems for commercial use. And we're concerned about sort of the large scale impact of automating these kinds of racial steering practices, which used to exist in person, but now could be compounded through these technologies and algorithms. So we have 3 research questions for our study. Number 1 is, do we see evidence of explicit racial steering in GPT-4's housing recommendations to prospective buyers or renters? So that is conditioned on knowing the demographic characteristics of the home seeker. Does GPT-4 guide minority home seekers towards neighborhoods occupied by people of similar background and away from white neighborhoods, for example, as well as does it guide these minority home seekers towards neighborhoods characterized by lower socioeconomic opportunity? The second research question is, do we see evidence of default whiteness? So this term is rooted in media theory, and it's the idea that somehow whiteness serves as a baseline against which all other minority groups compare to. So what happens if we don't mention race in our prompts, and how does GPT-4 sort of respond accordingly? And then our third research question for this particular study is, how does GPT-4's housing recommendations intersect with other demographic characteristics that are protected under national, local, fair housing laws? So this would be sex, gender, family status, sexual orientation, and source of income. So whether or not somebody reports holding a Section 8 voucher for housing subsidy. So I'm going to be talking a little bit about our prompt generation strategy now. This is our prompting schema. It was adapted by a paper done by Salinas et al. Last year, which looked at bias in large language models for housing recommendations. So we tested 5 demographic characteristics here, many of which are protected under the Fair Housing Act. So we're looking at sexuality, race, gender, kids, so family status, as well as source of income, whether or not the person's holding a Section 8 voucher. And then we tested this across 10 of the largest majority minority cities in the US. So there should be even less reason to expect default whiteness in ChatGPT's responses. And then we tested an additional renting versus buying condition. I should mention in the first 5 demographic characteristics that we also included an empty category, which allowed us to compare prompt results compared to default for all of these categories. I'm going to talk through, now that we have our prompt generation schema, I'm going to talk through how we generated our data. So across all of those prompt modifiers that I discussed, we have a total of 6,720 unique prompts. So for example, I'm holding a Section 8 voucher and I'm moving to the New York City area. What neighborhood should I rent a house or apartment in? And then so for robustness, we ran each unique prompt 25 times through the GPT-4 API. And then so we see an example response there. It's truncated, didn't have room to fit all of it in. But for example, the large language model returned choosing a neighborhood in the New York City area with Section 8 vouchers. So obviously it's encoding some of that context. And then it provides a list of neighborhoods. We then reprompt the model and ask for the list of neighborhoods in a standardized list so that we can analyze the neighborhoods recommended. And then we get an output shown there. So Washington Heights, Inwood, Harlem, Astoria, Flatbush, Jersey City, Fordham, and Bronx Park South. So now that we have a list of neighborhoods, I'm going to talk through our data analysis procedures. We have this list, and then we're interested in two major categories of relevant data. The first one are sort of ground truth measurements pulled from the census on economic opportunity as well as percent racial composition of these neighborhoods. The second large category are probabilities of recommendation across the different categories of demographic probes that we're testing. So I'm not going to go too much into the math here, but the idea is that we have GeoJSON records for the neighborhood boundaries scraped off of local government websites, where fuzzy matching the neighborhoods returned by GPT-4 with the neighborhood names in these boundaries, a cutoff of larger than 90%, and these were also validated manually. We used the percent overlap of census tracts with the neighborhood boundaries to determine a weighted average of neighborhood opportunity index, which is a sum of 7 z-scores for measures of socioeconomic opportunity in the neighborhood, including median rent, median income, sort of number of single mother-headed households with children. And so there's 7 of those. We also calculate the percent racial composition as a weighted sum of the census tracts, normalized by percent overlap. Separately, we calculate probability of recommendation scores. This is completely on the GPT-4 side, so it's not based on ground truth data. And so we're normalizing across all mentions of the neighborhood over all categories of a given demographic, and then calculating the percent mentions per category. And then so we have a data set there of neighborhoods in the rows, and then we have probability of recommendation, opportunity index, as well as some census demographic traits. I'll talk through our results now. I don't have time to present everything, but I'll talk through some of our major findings. So this is a map of New York City. And the top row are probabilities of recommendations by GPT-4 based on racial category. The bottom row marks ground truth census tract data. So the first thing to notice is that we have on the top left-hand side sort of the response in default prompts, which seems to align closely with the probability of recommendations given to white prompters. And then we also see on the bottom left here the opportunity index. So it's reverse coded. The darker colors mark neighborhoods of higher socioeconomic opportunity. It not only seems to overlap with the estimated percent of white population, but it also overlaps with both probability of recommendations for default and white prompts. So we already see maybe there's some evidence of default whiteness here, and we also maybe see some evidence of racial steering just between the overlap visually of probabilities of recommendations by race and then estimated census tract data. So in order to more fully quantify this, we looked at essentially the correlation between GPT-4's probability of recommendation against percent black population. And we see that predominantly black neighborhoods are being recommended at higher rates for black prompters, right? So those are the blue lines across all 10 cities that we tested. On the other hand, white and default prompts are being directed towards neighborhoods on average of lower percent black population. And these are the correlation coefficients for the lines that I presented above. The cities from left to right are organized by, are arranged by degree of geographic segregation. So this was taken from the Othering and Belonging Institute, with Chicago, for example, having the highest geographic segregation score, and then San Antonio having the lowest segregation score out of the 10 cities. And we see that there does seem to be some kind of gradation in regards to the racial steering effects that we find when comparing probability of recommendation for these 3 categories against percent Black population. We also tested this for percent white population. So we see similar trends where in response to white and default prompts, GPT-4 is recommending sort of neighborhoods with higher percentages of white residents. And then it's recommending to Black prompters neighborhoods with lower percentages of white population. And so each data point is a neighborhood, and we do the same analysis here. We see similar effects, again, with racial steering most evident in highly segregated neighborhoods. Okay, we do this for opportunity index. We also find that Black prompters are being directed towards neighborhoods with lower socioeconomic opportunities compared to white and default prompters. 5 minutes, wonderful. Okay, and finally, we look at Section 8 voucher holders. So Section 8 is a housing choice program for folks who are disabled or may not have as much financial resources, which limits their choice in housing options. And so the government will subsidize part of their housing, giving them the freedom to choose where they want to live. But we see that if this information is disclosed to GPT-4, that the large language model is essentially directing housing choice voucher holders towards neighborhoods with lower opportunity indices, which runs counter to the goals of the program. Finally, we're running a multilinear regression where the unit of analysis isn't the neighborhood, but it's the actual prompt. So YIJ here is the average opportunity index for all of the neighborhoods returned in a given prompt. And then we're running an OLS regression with fixed effects per city, that's the alpha there. We have some interaction terms between race and source of income, as well as gender and family status. And our main variables of interest, which I'm going to be talking about here, are the betas on the indicators for our socio-demographic characteristics of interest, which we modified. So the actual coefficients are in the paper. You can look at those, and I can also talk through those offline or afterwards if you have any questions. But we see that the characteristics that are linked to being recommended higher opportunity neighborhoods are straight, women, white, and having a family, and these are all the statistically significant effects. And the traits being linked to the traits that are being linked to recommended lower opportunity neighborhoods compared to default are all of the racial minority categories, save for one, in addition to holding a Section 8 voucher, which we see in this previous figure, and then seeking to rent versus buy. So I'm just going to talk through some of the main takeaways of our paper. The first is that GPT-4 demonstrates explicit racial steering, so conditioned on knowing the socio-demographic characteristics of the prompter. It will steer the prompter based on characteristics that are protected under the Fair Housing Act of 1968. Our second is that even when you don't give GPT-4 racialized information, when you withhold that information, it's still returning racialized answers because it engages in default whiteness. So when you don't tell it the prompter's race, it's going to assume that the prompter is white. And then our third finding is that GPT-4 is directing racial minorities, folks on Section 8, and renters towards lower opportunity neighborhoods overall. So you can find our paper here. We also have a GitHub repository with probabilities of recommendations for hundreds of neighborhoods across the 10 cities we studied by demographic category, as well as some code to run similar experiments on your own for future iterations of LLMs. So yeah, thank you for your attention. Happy to answer any questions.
Thank you, Eric. We have time for a couple of questions, if there are any.
Thank you. This is a great talk. I have two questions. So the first one, maybe I just missed your model, but like, how much of the lower opportunity result do you have after controlling for the racial steering? So that's one question. And then the second question is, so with Section 8 housing, there is expiration of the coupon. So it's imperative that people get a landlord that is willing to receive the Section 8 housing. And could the steering be, so you don't want to be put into a neighborhood where the landlord is likely to deny your application, right? And so I'm just thinking about that in terms of being steered towards areas where it may be lower opportunity, but landlords are more likely to accept the coupon.
Yeah, great questions, thank you. Let me just pull up the model. So your question was, when controlling for the coefficient, when controlling for racial categories, what are there any steering effects for the other variables that we examined? So yes, so we do see steering predominantly, the statistically significant effects are for Section 8 voucher holders and for renters. So the coefficients there are, when holding all else constant, those are the ones that are significant. And you can find those in the paper as well. The largest effect that we found in magnitude was for Section 8. And so I think related to your second question, that's a really great point. So we were very clear about, in our prompt design, to not disclose any preferences. So even with disclosing racial information, we're testing conditioned on knowing these things about the person, and there are thousands of ways that GPT-4 can infer this information. There are plenty of papers that sort of use more indirect prompting strategies. It's still engaging in this kind of behavior, even if you don't tell it your preference, right? So Section 8 voucher holders are not saying, give me neighborhoods where I will be less likely to be rejected by a landlord. And GPT-4 is just assuming those kinds of preferences, which I think is one point of one issue that sort of removes agency from the person. I also think that landlords also engage in this kind of explicit steering where they're less likely, they're less willing to take Section 8 voucher holders. And we're interested in the kind of systemic effects, even above that sort of individual preference, because we do see that kind of these stratifications across socioeconomic status are a way that categories of inequality like race are being curated, right? So the concern here is that these kinds of stratifications are problematic even at a systemic level, and in addition to the individual preference. So I think it's a complex question, right? But it's also a sociological one. So now that we have these results, like how do we determine as a group what these models should be doing? And I don't think we should be implementing these models until we have a clear sense of that. Yeah.
Okay, let's give Eric another round of applause. Is Yangxi Shang here? No. Okay, so it seems our second speaker is not here. So if anyone has another question for Eric, we could also take that, or we can move on to our last talk.
Yeah, so I'm curious, I might have missed this, but if you did any thinking about whether GPT would ignore preferences in favor of stereotypes at all? Like if you said you found the highest magnitude effect for holding a Section 8 voucher, if you were like, I am holding the Section 8 voucher, I would like to live in Soho, what neighborhoods should I live in? Maybe not that question because it's a silly, but you know what I mean? Like, would it subvert the stated preference due to the stereotype, or does stating a preference kind of reverse this?
Yeah, great question, thank you. So we didn't test for whether or not sort of stating a preference would reverse these kinds of racial steering effects. And I think there are studies being done on ways to sort of test whether or not the prompt itself could return an answer that violates fair housing laws, or if the question passes but the response is problematic, then there's another filter, sort of sandwiching the large language model. But I think it's worth asking. It's worth studying in the future. It's a good question. We didn't look at it.